Hello Year 11 and welcome to our third video here for our ninth topic, probability. We've looked at simple events, the probability of simple events so far, and also multi-stage events using both a table or a tree diagram to calculate those, right? Certainly to investigate them and to calculate the probabilities. Today we're going to look at complementary events. Now, complementary events is not when you see your grandma and she says you're looking very handsome. Not that kind of complementary with an E. And we're talking about everything else that might happen. So I've got an event, and that's going to group together some of the outcomes. Right? We've got our sample space. Some of the outcomes in that sample space belong to an event. All of the other ones belong to the complement of that event. We write the complement of an event, right, with a little dash or line above the symbol for it, above the event. Okay, and we use this word not a fair bit. So my event might be A. The complement of that event is not A. Right. So let's have a look here. Oh, now there's something else that's really important here. Now we use complementary events, right? We use them quite a bit to sometimes make a tricky problem much easier. Now, most of the problems where we want to use this idea of complementary events include the phrase at least. Where you see a question that has the words at least in them, what is the probability that at least one of these things happens? Then that's a good clue that the complement is the way to solve these. Now, if we come back to this idea of a sample space and some of the outcomes belong to one event and all of the others belong to the complement, then if we add the probability of those two events together, an event and its complement, the combined probability equals 1. One of those things has to occur or the other. They can't both occur, and there's no case where neither occurs. It will be one or the other, so the probabilities add up to 1. Now that in itself is not so helpful, but we can rearrange that simple equation to say that the probability of an event is equal to 1 minus the probability of the complement. Let's just say that again. The probability of an event is equal to 1 minus the probability of its complement. Now that does simplify a lot of problems. Let's begin here and have a look at an example. Myrtle flips 7 coins. Think back to our probability, to our tree diagram from the last exercise. Now, that's not a tree with 7 branches. No, that is a tree that forks 7 times. Right? That means that the size of this sample space, right, the size of this sample space is 2 times 2 times 2 times 2 times 2 times 2 times 2. 2 to the power of 7 is 128. You don't want to draw a tree with 128 branches at the end. Now, the question here is, what is the probability that at least one lands on heads? At least one lands on heads. Well, the complement of at least one head is no heads whatsoever, is all tails. Okay, there's lots of ways we could have at least one head. Okay, there's the first one, the second, the third, the fourth, the fifth, the sixth, or the seventh. And then there is the first and second, the first and third, and so on, right? I could have 1 head, 2 head, 3 head, 4 head, 5 head, 6 heads, or 7 heads, right? There's lots of ways that that could happen. There is only one way to have all tails, to have no heads. There's only one. So what I'm going to say here, and I guess this is a bit of a tricky question, unless you can work out that if I flip a coin 7 times, the size of the sample space is 128. Now, I'm going to say that the probability of no heads equals 1 out of 128. Right? Therefore, the probability of at least one head equals 1 minus 1 over 128 equals 127 over 128. There we go. That's how we use a complement to make a difficult problem much, much easier to solve. Okay, that's it for complementary events. If you've got any questions, jot them down. I'll see you in class.